Hi everyone, and welcome to this lecture where we're going to be discussing attention, especially as it relates to human motor control. And so I'm super excited that there are a number of you in this class who do have an interest in cognitive psychology, because this is actually one of the fields that contributed significantly to motor control. And actually, when I was a PhD student at Purdue, more than half of my classes actually came from the psychology department rather than kinesiology. And that really speaks to the fact that this field is multidisciplinary, and of course what we're dealing with are the processes that occur in the central nervous system rather than in the limbs and the muscles themselves. And so before we go into this, I think that everyone actually has an idea of what attention is, right? Whether we're paying attention or not paying attention. And indeed, the study of attention has had a long and checkered history in cognitive psychology, starting with James back in 1890, and it's been filled with debate and disagreement. And so, although we have an intuitive understanding about what it means to pay attention to an object or to an event, some people have suggested that everyone knows what attention is, and others have countered and saying that no one knows what attention is. And indeed, it's really hard to come up with a operational definition of attention. But regardless of, this discussion about the precise definition of it, there's definitely broad agreement that attention involves selecting some information for further processing and also inhibiting other information from receiving further processing. And actually it was William James, that should actually be 1890. In 1890, he said, "Everyone knows what attention is. It is taking possession by the mind in clear and vivid form of one out of what seems several simultaneous possible objects or trains of thought. Focalization, concentration, and consciousness are its essence. It implies withdrawal from some things in order to deal effectively with others, and is a condition which has the real opposite in the confused, dazed, scatterbrained state." Okay, so here we have some idea. We're not actually saying what attention is, but we are discussing what is required to actually pay attention to something. Okay, and so with that in mind, we actually can define attention with respect to its characteristics. So what we know is that attention requires consciousness. Okay, so we need to be either paying attention or not paying attention to something, in the sense that it's not something we can do if we are unconscious or sleeping. The second one is an awareness. We need to have an awareness of the surroundings around us, and that's why when we're not paying attention to something, we don't have that quite awareness of what is going on. And the third and most important part for our purposes is the fact that it requires cognitive effort. Okay, and by the fact that it requires cognitive effort in order to either inhibit paying attention to something or actually processing and selecting information, means that in this case here, it may conflict with some of the motor skills that we may actually be doing while actually navigating these very dense and convoluted environments. With the purposes of this class, we're actually particularly interested in the limitations that are associated with those characteristics in two ways. First, on the simultaneous performance of multiple skills, and second, on the detection of relevant information in the performance environment. So first, when I talk about the simultaneous performance of multiple skills, this is a term we call multitasking. And so when we simultaneously perform multiple tasks, attention can be viewed as a performance limiting factor. Okay, so here we have a situation where we've got a individual who's biking, and what you can see is that as their primary tasks, they're having to look out for environment and the hazards that exist there, such as road conditions, whether there's pedestrians, whether they need to overtake a vehicle, or whether there's oncoming vehicles or individuals coming towards them. And so when we talk about the attentional processes for that, right, we do know that they need to maintain physical balance, otherwise you're going to fall off your bike. as well as controlling the input from the input devices coming in through the ocular system, being able to break and maintain this speed control or cadence. And so typically people can bike more or less okay when they're just doing that by themselves. But if, for example, the individual is also engaging in a secondary task, for example, they may be looking at their cell phone or something like this and looking at a number that might be displayed, maybe it's a sound alarm or vibration alarm. What happens there is that secondary task takes the attention away from the primary task, so it shifts it like this, right? And by actually shifting it away from the primary task, or if it's actually the case where you're listening at the same time, maybe listening to a podcast, trying to perform those two things at once, paying attention to the environment and listening to your podcast, are typically going to result in performance limitations of either one or both of the tasks. So I can definitely tell you that humans possess a finite limitation in the capacity available to handle information from the environment. And so if you're trying to do two tasks at once, let's just call them task A and task B. What we can say is that if task A requires attention, then some or all of the pool of the limited attention capacity must be allocated to its performance. Okay? And if you add task B to it, and task B also requires a certain amount of your attentional capacity, it will actually compete for these limited attentional resources. One way that I like to think about attention is think about it like a cup or a bucket, right? And you have a finite amount in that bucket, let's just call it water, right? And so if in that bucket, your task A takes up 5 of the 10 liters of that bucket, and task B takes up 7 by itself. When you add them together, that is going to be above your actual natural limitation, and then you may probably see deficits. And so when the combined need for the resources actually exceeds the amount of attentional capacity available, then you're going to get what's called interference, where task B is going to interfere with the performance of task A. But what we have is we have 4 equally likely possibilities. That interference could mean that your task B will suffer while A is relatively unaffected. The second is that B could be unaffected while A suffers. Both A and B could suffer together, or task B could be prevented from occurring altogether while A is in process. Okay? And so I'd like you to think about these 4 possibilities and how this actually manifests itself in human mode control, whether it be in the sporting world or in the rehabilitation or in the training world, right? So what tasks, if you put them together, are going to result in one of these 4 possibilities? And this would, by the way, would be an excellent question on your take-home exam, where I'd ask you to provide an example of all of these 4 options. So a way to think about this more broadly is in this way. If 2 tasks can be performed just as well simultaneously as well as individually, then at least one of them does not require attention. And also, adding to that, we could also say that at least one of those tasks is automatic, okay, so it doesn't require cognitive control. If one task is performed less well when combined with a secondary task, then we've got a different situation. Then we can actually posit that both tasks are thought to require some of the limited capacity, and that both tasks actually require attention and the demands on attention. Okay? And so one way we look at this is by looking at this concept of interference. And interference, which we get when one task is performed less well when combined with a secondary task, can occur from 2 fashions. First is from structural interference, which is is due to actually a physical or neurological structure that causes the decrement. So for example, let's just take the eyes. Human eyes are pretty poorly designed, quite frankly. Don't get me started on the fact that we've got a thin piece of skin covering them. It's insane. But anyway, The eyes are basically like windshield wipers, right? Basically, if I'm looking to the left, both eyes look to the left. We can't really separate them like we can for our hands, for example. And so in this case, the eyes can focus only at one signal source at a time. And so if I present to you two simultaneous visual signals, both on the periphery, on the left and the right, we're going to get deficits in processing speed because of the structural limitation that we can't split our eyes. We have to focus on one task first, or one visual signal, and then we can focus on the second visual signal. The other source of interference is with respect to what we call capacity. And so, unfortunately, capacity is kind of like the leftover. And so when you rule out the possibility that structural interference between two tasks is actually occurring, then we actually infer that it's due to a capacity interference, such that you can't actually, there's a limit to how much of that bucket you have, and that the two tasks that you're doing actually lead to a more than what your bucket can actually hold. Now, there are a lot of different domains of attention: selective, vigilance attention, otherwise known as sustained attention, and divided attention. But for the purposes of this class, we're really going to focus in on selective attention. And this is when you allocate attention to different tasks or inputs, which can be either intentional or incidental, depending upon how a selective allocation of attention has been achieved. So intentional selective attention is when you purposefully or intentionally choose to attend to one source of information while actually avoiding or inhibiting attention to other sources. And this is typically the case, for example, when you're listening to the TV while ignoring your lover, or alternatively, when you're trying to, work on your homework and listen to these lectures, and your cat is just meow, meow, meowing in the background, right? So in that case, you're actually purposefully and intentionally inhibiting attention to your cat so that you can listen to my soothing half New Zealand voice. In contrast, incidental selective attention is when there's an involuntary capture of attention that usually occurs as a response to an external stimulus. So for example, you're in your car and you're just like driving along, paying attention to the road, and there you hear this other car backfire in the background. And so the car that's backfiring involuntarily captures your attention, right? And it occurs from an external stimulus. Alternatively, if we use our cat analogy, maybe you're listening to my e-lecture and you're just like hella into it and totally focused. And then your cat actually comes along and knocks things off the table, and then you hear your favorite vase crash onto the ground, right? That's incidental selective attention. So now that we know some of the basics about attention as well as sources of interference, we can talk about theories of attention. And this is the way that information from the external environment actually makes its way through our perceptive processes into the central nervous system, where we can actually process and make sense of that information. Broadly speaking, there are two theories of attention, or two camps basically. The first camp refers to a single channel filter theory, and this kind of theory posits that difficulty doing multiple tasks simultaneously occurs because of the inability to serially process multiple stimuli. And so the key term here is serially, right? In the sense that you can't do things in a serial fashion, you can't do them at the same time. In contrast, the multiple resource theories actually propose that there is a single central source of attention resources where all of the activities compete, but that the specifics about the stimuli as well as the needed responses actually differ. Okay? And if you're really interested in attention, go and get a PhD, because you can spend your whole PhD career studying attention. It's basically the same as memory. That stuff is super complex. Okay, so let us start with some of the single channel theories. So the original of the single channel theories actually comes from Welford, and Welford actually assumed that all processes required attention. And he conceptualized the human as a single information channel that could be occupied by one and only one stimulus response operation at a time. And ergo, if only one operation can be done at a single time, then any task that's attempted at the same time as another will actually be blocked. Okay? And so this is a severe source of interference. So Welford's theory can be actually conceptualized in this way, otherwise known as the stimulus onset asynchrony, or the psychological refractory period. And so this is the way that Welford conceptualizes it. If you do a single task like this, you have to first do that perceptual analysis, the response selection, and the execution, which basically looks pretty much like what I've talked about in human information processing, right? And so because Welford says is that you can only have one channel going through at a time, right? One stimulus response alternative at a time. If you try to do this second task at the same time, it cannot happen at all. It's going to be blocked. And so the way that Welford dealt with this was he had people do a series of dual task conditions like this, and he manipulated what's called the stimulus onset asynchrony, otherwise known as the time between when you present the stimuli for the first task relative to the second task. And what he found is that if you actually increase this stimulus onset asynchrony time so that the perceptual analyses, these green ones, don't overlap, then you can actually get away with doing two tasks at once. But it's actually that perceptual analysis stage which is causing the problems or this interference. And so the way that Welford thought about it, or what he called it, was the selective filter. And he uses this term called a bottleneck. And we still use this today to explain it. So this selective filter, in more kind of theories that were brought up by, for example, Broadbent, basically states that you've got this filter, and this filter actually occurs right here. And you've got numerous sensory inputs coming in here, right? It could be from the visual, the auditory, the motor at the same time. And this filter allows for certain stimuli to pass through for further processing down here, and any unintended stimuli will be filtered or lost. This stuff here that actually passes through the filter becomes available for short-term memory, manipulation of the selected information as well, that occurs prior to storage in long-term memory. And the stuff that doesn't make it through the filter gets lost, and we don't actually process it. So Welford actually discusses and says that the human is a single information channel, right? That you can only have one source of information coming at a time. But work by Broadbent actually took it in a different way. And he was the first to describe the human attentional processing system using the information processing metaphor, right? Where we've got the input, the black box, and the output. And so in this view, Broadbent proposed a so-called early selection view of attention. And in this case, humans possess information with limited capacity and select information to be processed in a more earlier fashion. So if we consider this to be a modified form of a human information processing model, we get inputs, for example, that are coming into the left ear and into the right ear. And then what happens is early in the selection process, we're going to block what occurs in the right ear, is going to hit that filter. But information coming into the left ear is going to make its way through the filter, meaning that it's going to actually involve some perceptual analysis, make its way into short-term memory, where we're actually aware of what it means and we're storing it. And then we actually get to a response, okay? And that's where he kind of put the theory. Put the bottleneck. Later versions move the location of the single channel to later stages in the sequence of processing. So if we view it from our original human information processing model, where we've got stimulus identification, stimulus selection, and response programming, Welford puts it right here at stimulus identification, right? Broadbent puts it a little bit further, just before, still in the stimulus identification phase. And what we'll discuss coming up is that Deutsch and Deutsch put that bottleneck a little further, and Stephen Keel puts it in the response programming stage. And so these later theories, regardless if we're talking from Deutsch and Deutsch or from Keel, assumed that early stages of processing were done without attention, but that attention was required at later stages of processing. So in this way, we can say that processing without attention implies parallel processing, and that a number of separate signals can be processed simultaneously without interfering with one another. So in this case here, we could actually be paying attention to an auditory stimulus while performing a forearm gripping motion while paying attention to this biofeedback, and that these two things can be done without interference. So, Broadbent and Deutsch actually theorize that there's a kind of filter and that it's located somewhere in the information processing pathway. And what they assumed is that many stimuli can actually be processed in parallel, which is why we have all three of them coming through here, and they don't require attention prior to reaching this filter, whether it be here or here. What's interesting, though, is that they say that when this filter is reached, only one stimulus at a time can be processed through it, right? And so let's take in the case of Broadbent, we're saying that we'll have some visual information, some conflicting auditory information, and maybe some proprioceptive information. That we can actually process all of these stimuli, but when we actually come to the filter, only one of those is actually going to go through and be processed, all the way to short-term memory and then a response. And so this is why we say that before here, we can actually do parallel processing. After here, information processing occurs in a sequential fashion and requires attention in the single channel. What I really believe, or what I think is that Keel is onto the right idea if we just focus on the single channel theory. And so Keel's theory of attention places the bottleneck at even later stages in the sequence than Deutsch and Deutsch. And what he assumes is that information processing is parallel and attention-free through both the stimulus response and the stimulus selection phases. But he puts the filter right here in response programming. So in this way, you could process those three inputs from the auditory, from the visual, and from the proprioceptive channels. But when you need to program a response, only one of those signals actually makes its way through for response programming and execution. And so what he says is that when you actually get to that filter, he calls it a memory contact, in which certain associates of the memory are stimulated, right? So maybe you hear your name, or you see someone you like, or something like this. Those kind of associates actually activate the stimuli, okay? And because all such stimuli contact memory at about the same time, selective attention determines which of these memory contacts will receive further processing. And so if we think about it like this, what's going to require further processing? Well, it's things like items and related categories to what you're doing, items that are closely associated with the stimuli, and aspects of early preparation for a movement that actually get triggered by that stimuli. And what he further goes on to say is that these processes are attention demanding. And so thus, if two processes are required at the same time, then decrements in performance are actually going to occur. Okay. And again, when I say that these processes are attention demanding, what I'm talking about is after the memory contact is made, then it becomes attention demanding. When it occurs before this filter here, it's not attention demanding, right? It's attention free. And these information streams can be processed in parallel. And so I'm going to stop this lecture here, but what I really want to impress upon you in this first lecture are three things. First is that when we're doing two things at once, there can be four possible alternatives, depending upon whether the tasks require the conscious and awareness and the cognitive effort associated with attention, or whether they can be actually processed unconsciously. Second, we need to understand that we can use interference as a measure of attention, right? By using these dual task paradigms and comparing the performance in these dual task conditions to what happens when the task is performed alone. Third, we should understand the difference between structural interference and capacity interference. And then the two types of selective attention, whether it be intentional or incidental. And so, of course, you can imagine here, I might ask you on your quiz or on your exam to provide me with examples in human motor control on intentional and incidental selective attention. Last, we covered the first kind of group of theories of attention, which are the single channel filter theories. And of course, even though that different researchers place that bottleneck or place that filter at different places, basically they say that the difficulty doing multiple tasks at the same time occur because humans cannot process multiple stimuli in a serial fashion. Well, actually, it should be in a parallel fashion. Change that. When I come back in the second lecture, we're actually going to move into some work on multiple resources theories. So that's the other camp, which tries to explain attention as a limited capacity resource. And then we're going to go into some fun stuff, including the types of interference that we could observe. We'll talk about the cocktail party problem, intentional blindness, because that has a lot to do with human motor control. And then we're going to look at how we select visual cues in the environment in order to actually pick up what we need to look at and, of course, to make appropriate motor actions. So I hope this was enjoyable for you. Please let me know if you have any questions. I'm more than happy to do more research on different aspects of attention, even though it's not my primary field of study. And post it in the forum if you need me. Ciao for now.